Good morning dear students, welcome back. I am your physics professor Dr. Nagaraj. So in my previous video I did few numericals on quantum mechanics. So especially I focused on wavelength calculation of matter waves and some problems on uncertainty principle. So I continue with the remaining problems on uncertainty principle as well as applications of Schrodinger wave equation, that is problems on particle in one dimensional potential well, calculation of eigenvalues, eigenfunctions, wave functions and wavelength also. Well, let us move on to the next question. The next question goes like this: how much time is needed to measure the kinetic energy of an electron whose speed is 10 meter per second, that is actual speed, with uncertainty of not more than 0.1%. Delta V is given. So you have to find out delta T, and also he is asking how far will it travel in this period of time. So during this interval of time, what is the distance traveled by the particle? Here the particle is nothing but electron. So it is clearly mentioned it is electron. Well, let us go ahead like this. Well, first of all, delta V we have to calculate. It is 0.1% of V, that is 0.1 into V is 10 divided by 100. It comes out to be 0.01. Now delta X into delta P greater than or equal to H divided by 4 pi, and this delta P can be written as M into delta V, that is greater than or equal to H by 4 pi. Why it is M into delta V? I do it here. P is equal to MV, delta P differentiate, it becomes M into delta V. I hope you got it. So we cannot differentiate M because M is constant. Okay, now delta X greater than or equal to H by 4 pi M into delta V, that is equal to 6.62 into 10 to the power of minus 34, that is Planck's constant value, divided by 4 into 3.14 into mass of the electron 9.1 into 10 power minus 31 into 0.01. Dear students, remember you have to do the substitution. Without substitution, simply by using calculator you do the calculation, you lose marks. Okay, well, I have done the substitution. Now I am doing the calculation. Meanwhile you also can do the calculation. So it comes out to be, just 1 minute, I will check. Okay, 9.1 and 0.01. Well, it comes out to be 5.796. 5.796 into 10 to the power of minus 3 meter. This is delta X. So how far will it travel? That is distance. So we know velocity is equal to distance traveled divided by time taken. Therefore, time taken delta T, not greater than or equal to, we can use equals symbol only here. Delta T is therefore is equal to delta X divided by V. Delta X is already there, 5.796 into 10 power minus 3 divided by 10. So finally delta T is equal to 5.796 into 10 to the power of minus 4 second. So this is the answer. It is a very simple problem, not a very complicated one. Well, let us move on to the next question. An electron is confined to move between two rigid walls separated by 20 angstrom. Find de Broglie wavelength representing first two energy states of the electron and corresponding energies. See, here he is talking about potential well. You know this problem. This is one of the important question. You can expect this for 10 marks. Calculate the eigenvalue and eigenfunction for particle in one dimensional potential well using Schrodinger wave equation. It is available in my videos. Please check. Well, this is a potential well of height infinity, width is A is given as 20 angstrom. We have to find the energy in the ground state. For ground state N is equal to 1, and then second state, that is N is equal to 2. So N is equal to 1 is ground, N is equal to 2 is first excited state or second allowed state. So N is 1 means ground state, and we call that as E0 state, and N is equal to 2 is first excited state, and we call it as E1 state. Please don't get confused. E1 is not N is equal to 1, but it is N is equal to 2. Like that, E2 corresponds to N is equal to 3, E3 corresponds to N is equal to 4, E4 corresponds to N is equal to 5, and so on. Okay, now first one, formula is En is equal to n square h square by 8 ma square. Now you take n is equal to 1. Take n is equal to 1. Therefore, E becomes E naught, that is h square divided by 8 ma square. You know what is h? Why it is h square? Yes sir, because n is 1. Well, h is 6.62 into 10 to the power of minus 34 whole square divided by 8 into 9.1 into 10 power minus 31 into 20 into 10 power minus 10 whole square. So this is the energy corresponds to ground state. Well, I do it. 6.625 to the power of minus 34 whole square divided by 8 into 9.1 to the power of minus 31 into 200, 20 into 20, 400 to the power of minus 20, because 10 to the power of minus 10 whole square. Well, I got the answer as 1.51. 1.51 into 10 to the power of minus 20 joule. This is E naught. If you want, you can convert this into electron volt, and you know how to do that. Divide by 1.6 into 10 power minus 19 comes out to be 0.09094 electron volt. This is the energy for the first state. Second state we will do now itself. You know, second state is E1, that is n square is 2 square h square by 8 ma square, sorry not 4, 8 ma square. See, this is nothing but 2 square, that is 4 into E naught. That whole thing, this whole thing is E naught. So that is 4 into 1.51 into 10 to the power of minus 20. So substitute and simplify. This becomes 4 into 1.51, that is equal to 6.04. 6.04 into 10 power minus 20 joule. Or you can put it in electron volt, that is 4 into 0.094, that is 0.376 electron volt. See, even if you don't express in electron volt, you will get marks. That is not an issue. Well, this is energy calculation, but he is not only asking energy, also asking wavelength calculation. Now first calculation of wavelength, lambda is equal to h divided by root of 2me. So now you put lambda 1, this becomes E naught. Put lambda 2, this becomes E1, 2m E1. Okay. Well, let us simplify. That is, once again you have to do substitution. Well, 6.625 into 10 to the power of minus 34 divided by square root of 2 into 9.1 into 10 power minus 31 into energy is already calculated, that is E naught, 1.51 into 10 to the power of minus 20. So simplify this. Well, I will do it. Of course, square root is for the full denominator. 2 into 9.1 to the power of minus 31 into 1.51 to the power of minus 20 for this square root, and then take it to the numerator, multiply by 6.625 to the power of minus 34. The answer is 3.99, approximately 4 into 10 to the power of minus 9 meter, that is 4 nanometer. Okay, this is wavelength for ground state. Let me try the wavelength for the next state, that is excited state. You have to get half of this value, that means 2 you have to get. Let us check. Lambda 2 is equal to, right, 6.625 into 10 to the power of minus 34, that is h value, divided by root of 2 into 9.1 into 10 power minus 31 into E1. It is not 1.51, but it is 6.04 into 10 to the power of minus 20. Well, simplify, dear students. Meanwhile, I will also do it for you. 2 into 9.1 to the power of minus 31 into 6.04 to the power of minus 20 for this square root. For this this I have to take to the numerator, and then this I multiply by 6.62 to the power of minus 34. Yes, I get it as 1.99. Approximately it is 2 into 10 to the power of minus 9 meter. So this is the wavelength for second excited level. So you can try this for even third one, fourth one, fifth one, etc. This is very simple problem. Calculation may be lengthy, but concept wise it is not too much complicated. Well, I move on to the next one. Find the probability. This is slightly lengthy problem. Find the probability. Actually it should be probability density. Find the probability density that a particle in a box of width A and infinite height can be found between 0.45A and 0.5A for the first excited state. Dear students, I will explain the problem first. See, look at this. This is the potential well of infinite height. This symbol represents it is infinite height. Now if you find a probability from x equal to 0 to x equal to a, definitely probability is 1. See, you know probability is nothing but integral of modulus of psi square into dx between the limits x1 and x2. I call it as equation 1. If x1 is equal to 0, x2 is equal to a, that means you are integrating from the beginning to end. Definitely probability is 1, that is 100%. But I don't want probability from beginning to end. I want somewhere in between, somewhere here. So that this is x1 and this is x2. In this region, what is the probability? See, x1 and x2 are given in this question. x1 is given as 0.45 a. x2 is given as 0.5a. The width is very small. In a very small region we have to find the probability. Then how to do this? Well, you know the equation for psi. We know that psi is equal to root of 2 by a sine of n pi by a into x, where n is 1, 2, 3, etc. Look at the question. Particle is assumed to be in the first excited state. So for first excited state, take n as 2. Let n is equal to 2. This is what I told you in the previous slide. Therefore, psi becomes root of 2 by a sine of 4 pi by a, 2 pi by a into x. In the place of n I substituted 2. Okay, now consider the probability equation. So substitute in equation or from equation 1, whatever you want you write from equation 1. P is equal to integral of psi. Psi is root 2 by a whole square. Whole square is 2 by a into sine square 2 pi by a x into dx. Of course, the limits are from x1 to x2. Till here one step. Now onwards it is pure mathematical operations. You have to integrate it using your mathematics knowledge. I take 2 by a outside, and inside whatever I have, no, sin square theta, I write it as 1 minus cos 2 theta. That is cos 2 into 2 pi by a x, whole thing divided by 2. So sin square theta is 1 minus cos 2 theta into dx as it is you write, and the limits are from x1 to x2. Okay, limits are x1 to x2. Dear students, my handwriting is not that good, but please bear with me. I think you are able to make out. Okay, well, substitute and simplify. Well, p is equal to, well, I cancel this 2 and 2, and I left with 1 by a integral of 1 into dx, right, minus again 1 by a, means I am splitting this 1 minus cos 2 theta, integral of cos 2 into 2 pi means 4 pi by a x into dx. Between the limits, here also x1 and x2, there also it is x1 and x2. Okay, you know how to simplify. Please try on your own. Meanwhile, I will also do. Later on you can compare with this. So 1 by a integration of dx is x and the limits are x1 to x2 minus 1 by a, integration of cos is sine, so it is a by 4 pi into sine of 4 pi x by a between the limits x1 and x2. Okay, then this is equal to 1 by a. Now you can write x2 minus x1 minus 1 by a. Okay, a cancel here, so it becomes 1 by 4 pi into sine of 4 pi x2 by a minus sine of 4 pi x1 by a. So I continue here the remaining, that is equal to first one 1 by a into x2 is 0.5a minus 0.45a. Okay, first term minus 1 by 4 pi into sine of 4 pi into 0.5a by a minus sine of 4 pi into 0.45a by a. This step is bit lengthy because I am applying limits. Okay, next step will be not that much lengthy, that is equal to 1 by a into 0.05a. Okay, minus 1 by 4 pi. I leave it to you, please check. First term becomes 0. How it becomes 0? Please convince yourself. I just put it in wordings, you check. A cancel. Okay, this a and this a cancel. 4 into 0.5 is 2, so sine 2 pi is 0. Similarly here also a and a cancel. 4 into 0.45 is 1.8, so minus sine of 1.8 pi. Okay, close the bracket. So here again a and a cancel. I have 0.05 minus 1 by 4 pi into minus. Now you take the calculator. Dear students, you can do this in two ways. Number one, in degree, or number two, in radian. Suppose if you want to do it in degree, check the calculator whether it is in degree mode or not. If it is not in degree mode, bring it to degree mode and continue. If you want to perform in degree mode, remember pi has to be taken as 180. If you want to do it in radian mode, bring the calculator to radian mode and then go ahead. In that case, pi must be taken as 3.14. So pi is which pi? Which pi I am talking? Do you know? I am talking about this pi. See this pi, not 4 pi. E pi alla. ಇದು ಯಾವಾಗಲೂ 3.14 ಇರುತ್ತೆ. ಈ ಡಿಗ್ರಿ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಟರ್ಮ್ಸ್ ಜೊತೆ ಬರ್ತಾವಲ್ಲ, ಅವು ಐದರ್ ಡಿಗ್ರಿ ಆರ್ ರೇಡಿಯನ್ ಇರ್ತವೆ. ಇಲ್ಲಿ 1.8 ಪೈ ಅಂತ ಬರೆದ್ರೆ ಇಟ್ ಕ್ಯಾನ್ ಬಿ 1.8 ಇಂಟು 360 1.8 ಇಂಟು 180 ಆರ್ 1.8 ಇಂಟು 3.14. ಸೊ ಇದನ್ನ ನೀವು 180 ತಗೊಳ್ಳೋದಾದ್ರೆ ನಿಮ್ಮ ಕ್ಯಾಲ್ಕುಲೇಟರು ಡಿಗ್ರಿ ಮೋಡಲ್ಲಿ ಇರಬೇಕು. ಇದನ್ನ ನಾನು 180 ತಗೊಳ್ಳಲ್ಲ ಸರ್, 3.14 ತಗೋತೀನಿ ಸರ್ ಅನ್ನೋದಾದ್ರೆ ನಿಮ್ಮ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ರೇಡಿಯನ್ ಮೋಡಲ್ ಇರಬೇಕು. ವೆಲ್, ಐ ವಿಲ್ ಟ್ರೈ ಇನ್ ಡಿಗ್ರಿ ಮೋಡ್. ಮೈ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಇಸ್ ರೈಟ್ ನೌ ಇನ್ ಅ ಡಿಗ್ರಿ ಮೋಡ್. ಐ ವಿಲ್ ಟ್ರೈ. ಹೌ? press the sign, open bracket, 1.8 into 180, close the bracket, equals. So I get answer as minus 0.589. If you want, you can check this even in degree mode also. Definitely it comes out to be same. That is minus, 1 minute, minus, this minus is already there. I am getting additional minus 0.587. So this is about the sine of 1.8 pi. Okay, now go ahead. That is equal. Now you can simplify this. So this becomes is equal to 0.05 minus 1 by 4 pi into 0.587 because minus into minus becomes plus. So that is equal to 0.05 minus, well, it is 0.587 divided by 4 divided by 3.14 comes out to be 0.046. This is a very lengthy problem, but this is very important problem in fact. So now the difference 0.5 minus 0.46 is 4 into 10 power minus 3. This is the probability density. In terms of percentage, if you want to write, this comes out to be 0.4%, because in terms of percent, when you try, you have to multiply it by 100, then it becomes 0.4. Even if you stop here also, no problem, or you can write this as you can write this even as 0.004 also you can write, right? So that's all about this particular problem. Well, with this I move on to the next question. Next question comes here. Evaluate the de Broglie wavelength of an electron present in an infinite potential well of width 10 angstrom. Assume that electron is in the ground state. I think this is already done in one of the previous problems. Only thing there it was n is equal to 1 and 2 states. Here it is only n is equal to 1 state and the ground state matra. Well, I will try to do this problem in different manner. Okay, it goes like this. A is 10, okay, angstrom of course. N is 1 because ground state. Now let us do one thing. E is equal to n square h square by 8 ma square, and lambda is equal to h divided by square root of 2 me. Okay na? Substitute E in this case. Then lambda is equal to h by 2m into n square h square by 8 ma square. Simplify, m cancel, h square h cancel, 2 1s are 2 4s are cancel. So finally I left with 1 in the numerator. In the denominator it is n square by 4a square, correct? So lambda is therefore 4a square by n square, that is 2a divided by n. You can use it for any state. So now put a is equal to 20, n is equal to 1, lambda becomes 2 into 20 angstrom divided by 1, that is sorry, not 20, sorry, this is a 10, it is given as a 10, this is 10. Okay, now simplify. N is a is 10 angstrom, so 2 into 10 divided by 1 is equal to 20 angstrom. So this is the wavelength of a matter wave when electron is present in the ground state or the zeroth state. Well, we will move on to the next question. This is again probability. A particle moving in one dimensional box is described by wave function. Nodi. Wave function I used to write it as root of 2 by a sine of n pi by a into x. This is the general form. This is the general form, okay. But in this particular problem, psi is given as x into root 3. After simplification, we have this psi. Under some circumstances, psi has reduced to this. When x is between 1 and 0, that means the lower limit and upper limits are defined. Find the probability density in the interval of 0 and 1 by 2. That means x1 is 0. But remember, x2 is not 1, it is 1 by 2, that is 0.5. Okay, no problem. P is equal to integral of modulus of psi square dx between x1 and x2. That is integral of x root 3 whole square into dx between x1 and x2. Okay na? So that is integral of 3x square, because square root of 3 whole square, into dx between x1 and x2. Very simple problem it is. It is 3 into x square is x cube divided by 3 between the limits x1 and x2. Okay, so this is the integration of x square. Now cancel 3 and 3. We have x cube between x1 and x2, that is x2 cube minus x1 cube, that is equal to x2 is there 0.5 cube minus 0 cube. 0.5 is 125, that is 125, 0.125 minus 0, it is nothing but 0.125, that is how much? 12.5%. So this is the answer. Did you find it very simple? I hope you find it very simple. Well, I give you one similar type of problem for you. Well, you try to do it on your own. You pause the video, do it on your own and compare your answer with the answer what I am getting here. Okay, so anyway I will do it here. Meanwhile you also try on your own. The question is like this. A particle is moving in one dimensional potential well. Width is 25 angstrom. Okay, see, whenever you see a problem, better you write the data. Assuming particle is in the ground state, that is n is equal to 1. Here lies the probability density. Find the probability density in an interval of 5 angstrom. That means x2 minus x1 value is 5 angstrom. Symmetrically about a by 2. Here lies the whole problem. Here lies the whole problem. I will explain the problem. How to choose x1 and x2 I will show you with the help of one diagram. Look at this diagram. Dear students, observe this diagram carefully. I have taken this full length as x, full length as a, sorry, not x, a. Exactly center point is a by 2. This is a by 2. Are you following? No, ಕಾಣಿಸ್ತಾ ಇದೆಯಲ್ವಾ? This is a by 2. ಈ a by 2 ನ ಸೆಂಟರ್ ಆಗಿ ಇಟ್ಕೊಂಡು this side you mark x1, that side you mark x2. Center ಅನ್ನ ಇಟ್ಕೊಂಡು this side you mark x1, that side you mark x2. So x1 to x2 gap is 5. So this is the center of 25. Center of 25 is how much? Sir, it is 12.5, sir. So 12.5, this side less, that side more. So this side how much less? How much less can you guess? Totally it is 5. Nodrappa, x1 to x2 it should be 5. x1 to x2 5. Idu center. Hagar ee kade 2.5 irbekalva, ee kade 2.5 irbekalva. So this side also 2.5, that side also 2.5. So keeping 12.5 reference minus 2.5 this side plus 2.5 that side, that is what that word symmetrically means. That's what this word symmetrically means. Sorry. Well, symmetrically means, symmetrically andre ee kadegu ashte gap, aa kadegu ashte gap, center in the this side, that side. With this much explanation, now you are able to write the values of x1 and x2. What is x1? Yes sir, it is x1 is equal to 12.5 minus 2.5, that is 10 angstrom, sir. x2 it is 12.5 plus 2.5, 15 angstrom, sir. See, x2 minus x1 is 5 only because it is 15, this is 10. So like this we have to decide x1 and x2. Now P is equal to integral of 2 by a sine square pi by a x into dx. One step I am skipping here. You know which one? I should write root of 2 by a sine n pi by a x into dx whole square. Anyway, it is decided that n is 1 for ground state. So I have taken n is equal to 1 and I have squared it. That's why this step. It is 2 by a integral of sine square pi x by a dx. It is between x1 and x2. Okay, go ahead. It is 2 by a as usual. How? 1 minus cos 2 theta formula. Integral of 1 minus cos 2 theta 2 pi x by a into dx whole thing divided by 2. That is 1 minus cos 2 theta by 2. 2 cancel, that is equal to 1 by a. Of course it is x1 to x2 integral of x1 to x2 dx minus 1 by a integral of x1 to x2 into cos 2 pi x by a dx. Almost over. Now you substitute, simplify. Integration of dx is x 1 by a into x2 minus x1 minus 1 by a into a by 2 pi into sine of 2 pi x2 by a minus 2 pi x1 by a. Got it? So this way you have to proceed. Okay, I hope you are able to manage. Anyway, you pause this and do it. This is also one of the expected question only. So that is 1 by a is 25 into 15 minus 10 minus a cancel 1 by 2 pi. Well, actually I made a mistake here. I should write this as, just 1 minute, I should write this as sine of 2 pi x2 by a minus sine of 2 pi x1 by a. Sorry. Okay. 1 by 2 into sine of 2 pi into x2 is 15, a is 25 minus sine of 2 pi x1 is 10 divided by 25. That is equal to, this is 5 by 25 minus 1 by 2 into, this is sine of, please check, 3 5s are, 5 3s are, 5 5s are. So finally it is sine of 6 pi by 5 minus 5 2s are, 5 5s are, it is sine of 4 pi by 5. Again you take the calculator. Well, this is equal to 5 by 25 means 1 by 5, that is 0.2 minus 1 by 2 into, well, take the calculator, check whether it is in degree or radian mode. Now I will do it in radian mode. Okay, well, I keep it in radian mode. You must know how to go to radian mode. Well, press the sign, open bracket, 6 into 3.14 divided by 5, close the bracket. So it comes out to be minus 0.587 minus of, let me check this one also, sign, open bracket, 4 into 3.14 divided by 5, close the bracket. It comes out to be plus 0.587. So this is what I got. So now you simplify the whole thing. It comes out to be 0.2 minus 1 by 2 into, inside it is 1.177 minus 1.177. That is equal to 0.2 plus 1.177 divided by 2 is 0.58, sorry, 1.177 divided by 2, 0.58. So this is equal to 0.2 plus 0.588. So this is nothing but 0.788. Okay, let me check once again. Let us please cross verify. 5 by 25 is 1 by 5. Okay. So this is minus sign, right? Let me check sign. Okay, 6 pi by 5, sign 4 pi by 5. Okay, let me check. You please keep checking. I will check this. 6 into 3.14 divided by 5. For that sign 0.586, correct. 4 into 3.14 divided by 5. 4 into 3.14 divided by 5. For that sign, yeah, 0.588. Okay, 0.588 plus 0.588, 1.176, right? 1.176 divided by 2 is 0.588. Okay, plus 0.2 plus 0.2 is 0.788. Okay, so this is 78%. So answer is 78.8%. Dear students, please cross verify the calculation. If there are any mistakes, you do it once again and take what answer you get, that as final. Anyway, I cross verified it. Okay, well, let me verify once again. Yes, n is in the ground state, particle is in the ground state, so n is equal to 1. Well, I write that by different color, so n is 1, correct. A is 25, correct. Difference is 5 angstrom, correct. Now x2 is 12.5 minus 2.5, 10. Why it is 12.5? Because half of the potential well, x2 is 12.5 plus 2.5, 15, it is correct. Now integration, 2 by a, that is square root of 2 by a is becomes 2 by a, psi square pi by a. Okay, next sin square theta, I write it as cos theta, 1 minus cos 2 theta by 2, 2 cancel. It is 1 by a into integral of dx minus 1 by a into cos 2 theta, 2 pi by a into x. After integration, it is x2 minus x1, a cancel, sin 2 pi by x to a, sin 2 pi by x, 2 pi x1 by a. So this is also correct. So this step is also correct. Well, that is equal to 1 by 25 into 15 minus 10, that is 5 by 25, correct. 1 by, yeah, this is the problem. Yeah. See, this is the mistake. 2 pi I should write. Yes, I made a mistake. So this is not 1 by 2, it should be 2 pi. Yes, this is 2 pi, dear students. Well, sorry. Well, till here we are correct. This step onwards we are wrong. Okay, let me do it for you. Please excuse me, it happens. That's why I asked you to cross check it once. 1.177 divided by 2 divided by 3.14, it is 0.18, 0.187. So to this I have to add 0.2, it comes out to be 0.387. So it is 38.7%, dear students. Sorry for the mistake. I am extremely sorry. I forgot to put pi. See, this being a teacher, I myself did mistake like this. So I can understand your situation. In the examination, there will be a sort of indirect pressure on you. Time constraint will be there. So please try to manage the time. Don't get confused. Don't look that side, this side. Don't get deviated at all. Well, with this, I stop the discussion on numerical problems from quantum mechanics chapter. I will come back to you with few more numericals on other modules. Meanwhile, I am uploading videos of superconductivity. Please watch them, share your comments, like the videos and subscribe so that I can go ahead with more confidence. Okay, your feedback matters a lot for me. Thank you, dear students. Thank you very much.